talking about the Finkelstein reaction. The Finkelstein reaction was actually named after a German chemist named Hans Finkelstein. It's an SN2 reaction that involves the exchange of one halogen atom for another. Usually it's iodine or fluorine replacing bromine or chlorine on the alkyl halide. One alkyl halide is converted into another alkyl halide by reacting with a metal halide salt. So this is an example of a Finkelstein reaction where chlorine is getting replaced by iodine on the alkyl halide.
Okay, so what I have drawn here is the mechanism for the example that we saw in the PowerPoint. So what you'll see is that the bond with the chlorine is breaking, and that bond is going back onto the chlorine and adding an electron pair to the chlorine. And the pair of electrons on the iodine is attacking that carbon. Okay, so what I have drawn here is actually the transition state for the Finkelstein reaction, because if you remember, SN2s don't have intermediates. They only have transition states because it all happens in one step. So you'll see that the carbon isn't completely bonded to either the chlorine or the iodine.
Now that we've gone over the mechanisms, we can start to go over the energies for this reaction. So what we have here is a reaction energy diagram. So you can see that the reaction energy diagram for a Finkelstein reaction looks about the same as it would for an SN2 reaction. It's not that much different because it is a form of an SN2 reaction. So the transition state for this reaction has more energy than both the products and the reactants. So what that means is there's a higher activation energy for this reaction. Okay, also based on the reaction energy diagram, we can come up with some predictions for this reaction. So because the products of this reaction, if you remember, have less energy than the reactants of this reaction, delta G will be a negative number, making this reaction exergonic. Because delta G is negative, and what we know about the relationship between delta G and K, we can predict that K is greater than 1, meaning that this reaction would be considered spontaneous. It would be a spontaneous reaction. And one thing that we could do to speed up this reaction is Le Chatelier's principle says that the more iodine you add, the faster the reaction will go because it's based off of an equilibrium point. So this is an example of a Finkelstein reaction in recent literature. This was an article written in 2017, and so it's called Purine-tagged ionic liquid separable organic catalyst for SN2 fluorination. So in this study, purine substituted imidazolium-based ionic liquids, or PILs, were prepared as organic catalysts for the SN2 fluorination using alkali metal fluoride, which is a Finkelstein reaction. So the PILs were found to significantly increase the reactivity of the metal fluoride in the Finkelstein